Hello, Dr. J here. In this presentation, we'll be building an electromagnet. The electromagnet in this example consists of three simple components: a nail, some insulated telephone wire, and a battery source. Here we form an inductor by wrapping this wire around this nail. And when we hook it up to the voltage source, a constant voltage source, we basically get an electromagnet. So the nail serves as what's also termed as a core, shown here. And when we hook up a voltage source, basically we form some invisible and stationary flux lines. These flux lines is a magnetic field that stores energy. This is used when the current going through the wire starts to decrease, and that in order to keep the current constant, it basically grabs energy from the magnetic field to keep the current constant. As I mentioned in an earlier video, the inductor has inertial properties resisting the instantaneous change of current. Now when the current starts to decrease, it basically grabs energy from the magnetic field in order to keep the current constant. Now with this polarity shown, you have the North Pole here and the South Pole shown here for this given set of polarities. And note, when I reverse the position of these polarities, then the positions between the North and South Pole will also be switched. The magnetic field, as we move radially away from the nail, gets weaker and weaker. We can get stronger magnetic fields by having a larger voltage source. Larger voltage source implies a larger current, which implies a stronger magnetic field. Again, the magnetic field gets weaker as you move away from the nail. So here's a quick demonstration of this particular electromagnet. Using the components I discussed earlier, here's a simple demonstration of applying this temporary electromagnet where I pick up a screw. There you have it, and you can do this experiment for yourself as well. Hopefully this example shows how an inductor can be used as an electromagnet. So what we had was that a stationary and magnetic flux lines are formed when you have a constant current. A nail becomes a temporary magnet as long as a voltage source is provided. And we have a bigger current means that we can have expanded flux lines. A smaller current means we have contracted flux lines. And in the later videos, we'll show that when a conducting wire cuts the flux lines, a voltage is produced on the wire.